The area of trapezoid is 150 square feet. Its bases measure 12 and 18 feet in length. What does the height measure? All right, so we've got some square footage here. We've got lengths of bases that are in just feet, not square feet. And we're going to find that height also in feet. All right, we're going to be looking for that height in feet. It's always nice when we go to these area type problems that for most all of them, first of all, it's a two-dimensional figure. All right, it has length and it has width, but it's got strange things going on. It's got two bases that run parallel, and also it's got this height that runs perpendicular to each of those bases, all right, and intersects them, making a right angle. Your situation is kind of fluid here. I mean, that 12 and 18, they're not the same. They won't be. It's a trapezoid, all right? So the formula that we're going to use here is the area of the trapezoid, and I like to call it an area of a trap, okay? A trap. How about that? Equals 1/2 the height, which we'll call h, times the sum of our bases. Now, there are two of them. It doesn't matter which one we call 1 or 2, all right? But we're going to use them both. We're going to use them both. So there's base 1, there's base 2. We're looking for the height, and there's this little pesky half that throws some people off occasionally, all right? It shouldn't be a problem today, all right? And I'll tell you why in just a minute. Now, over here, let's plug some numbers in. Let's substitute. We've got a 150 rocking over here. It's going to go right in there. That is the area of our trapezoid. We have a 1/2. We don't do anything with the 1/2 yet, okay? We are going to make that h just stay as an h because that's what we're looking for. That's going to be our variable. We call it x, n, whatever. I'm going to call it h for height. How about it? And then we've got the bases that we want to add them together. How about it? We're going to 12 plus 18. Just put those things in there again. 12 and 18, it doesn't matter which one comes first because, you know, addition is commutative. Y'all remember that word? Commute with a T-tative, all right? So let's see what's going to happen. We can certainly add those together, and you know what? We're going to be able to take half of that number without any much trouble, I believe. So we've got a 1/2, we've got a height, and we've got a 30 now. We've got a 30 for the base sum. We've got 150. Now, a couple of ways we could go here. Really and truthfully, we've got 3 ways, actually. We could divide 30 into 150. Seems a little complex, but that go 5 times, and then work with the 1/2. We could take half of 30, which I like best. That would give me 15. But we could also go along and say, well, we got a half sitting here. We could double that 150, and we get 300, all right? You say, well, Ernie, is it going to give us the same answer? Yes, it will. Either way we do it, however we work this one out. But I'm going to go ahead and just take 1/2 of 30, all right? That's going to leave us with 15 times the height, 15h, right there it is, 150, and you know what? That divides evenly and divides nicely. We're going to say 15 divided into 150, using our division property of equality to finish this little puppy off, and that puppy's height is 10 feet, and that would be 10 feet, not square feet, but feet, all right? So there's your story on the problem of the day today, all right?
For more math help, visit TNLearn.org.